Hello and welcome to my talk on the topic of chaos engineering and how we have implemented it at my current employer, Porsche Informatik, to increase our availability and performance. That's the official title of my talk. Unofficially, I like to call it, hey, let's turn off the database and see what happens. A little bit about myself at first. I'm Carolin Schuntermann. I'm a Bachelor of Science in Engineering. I studied Media Technology and Design at the University of Applied Sciences, Upper Austria. And once I graduated there, I started working as a Java software developer at Porsche Informatik. Well, that's officially at least. Unofficially, it feels more like full stack most days. So let me give you a quick table of contents about what I'm going to show you. First, I want to tell you about what the heck is chaos engineering. Then I will get into our Porsche Holding Salzburg, or abbreviated to PHS identity provider. I will further elaborate on our architecture of chaos, and last but not least, there will be a live demo of our database outage. So, point number one. What the heck is chaos engineering? And when you hear the word chaos, you probably think about something like this. Chaos. So, as I found out, there are multiple definitions for the word chaos. One of them being complete disorder and confusion. Does this look like complete disorder and confusion to you? To me it does. Oh, that gives me the heebie-jeebies. I don't like this picture at all. Right. But it's not the only definition there is. Another one, the formless matter supposed to have existed before the creation of the universe, something Greek mythology, which is possibly also an interesting definition, but in this case also not the one we're looking for. And then I found a third one, a definition found in the field of physics, and I'm just going to read this because it's a little bit of a mouthful. The property of a complex system whose behavior is so unpredictable as to appear random, owing to great sensitivity to small changes in conditions. Yeah, what it said. There is also a theorem about this that you may have already heard about, which is the chaos theory. I checked it out a little bit. It's honestly super interesting, though we're sadly not going to go into it, but I definitely recommend looking it up on your own because yeah, it's really cool, gotta say. All right, coming back to our original question, what the heck is chaos engineering? I found a nice definition by principlesofchaos.org, which says, chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Or, in simpler terms, we want to make sure that our system behaves normally even under abnormal conditions, and we do that by testing our system under these exact abnormal conditions. Could be, for example, server crashes, hardware failures, internet outages, denial of service attacks, and so on. So there is a basic idea to chaos engineering, which is a four-step experiment, starting with you define a steady state. Steady state is the measurable output of your system that indicates normal functioning behavior. Based on the steady state, you make the hypothesis that you have two groups, an experimental group and a control group. One of these groups, the experimental group, you will put your tests on, and the other one you leave alone. And your hypothesis is that in the end, there will be no measurable differences between these two. Wait, that just spoiled point 4. Oh well, whatever. Just forget what you just heard. Anyway, you create this hypothesis that no matter what you do, these two groups will remain the same. Then you introduce variables. These variables are, as I already mentioned, real-life events such as server outages, hardware failures, and so on. And I already spoiled it. After that, you check for differences in your experimental group and the control group. And if you see that there are certain changes happening in your experimental group, well, that means your chaos engineering was successful. You have some points you need to fix. And from this, we can deduce fairly simple quote that I've come up with myself. As the effort required to disrupt a system increases, so does its reliability. Obviously, right? So, based on these 4 steps, we can now deduce some advanced principles. I also got these from Principles of Chaos. There are 5 in total, so right, let me get right into that. First, as I already mentioned briefly, you want to base your hypothesis on your steady state. And this means you want to have measurable values. You want to be able to look at numbers, data, analyze it, and say, okay, my system works. That's the important part. You want to ensure that the system works, not how. Chaos engineering doesn't care what happens inside of your application. It just cares about, does it work or does it not work? Examples for these metrics could be throughput, response times, latency percentiles, error rates, the delay in switching to a backup service, server reboot time, and there's many more. Then you use real-world events. Evidently, you want to be sure that your system, which you run in the real world, will also be able to keep working when real-world event happens. For example, as I just mentioned, there are outages possible, there are attacks, cybercrime is at an all-time high, there are multiple ways that your application could stop working, so there are a lot of variables you can choose from. Right. This one might just make your hair stand on end a little bit. Run experiments in production. Don't worry, it's not recommended to start testing in production, but naturally, your production environment will differ from your testing environment. And no matter how good your testing environment is, you can never be 100% certain that the tests you run in the testing environment will have the exact same effects as in the production environment. Therefore, you want to eventually move to running your tests in your productive environment. All right, 2 more. Automate experiments. It makes sense that in order to get reliable data, you want to have your experiments running in regular intervals, and therefore it is recommended that you create services that automatically run your experiments, but also analyze them. And last but not least, you want to, of course, minimize the blast radius. Especially when you run your experiments in production, there will be users and clients that will notice certain changes happening. So you want to choose small packages of testing where you know what's to be expected, what possible fallout there could be, and of course also inform your end users so that they don't go running down in the door of your support center when something doesn't work as planned. All right, let me summarize that real quick. You want to have a measurable steady state, you want to use real-world events, you want to test in production at some point, not initially, I don't recommend it at least. You want to automate your chaos tests, and you want to minimize fallout. So, what is it now that makes chaos engineering so special in comparison to other quality assurance practices? For this, I got another quote from principlesofchaos.org, which says, "Where other practices address velocity and flexibility, chaos engineering specifically tackles systemic uncertainty in your distributed systems. The big advantage of this being is you can innovate much more rapidly at a greater scale without having to sacrifice quality and user experience, except for the minor fallout that you may have from your tests, of course." Okay, that was chaos engineering in a nutshell. I hope you're all still with me. Don't worry, it should get easier from now on. I think, hopefully. All right, number 2. Let me introduce you to our Porsche Holding Salzburg identity provider. I will abbreviate it to PHS-IDP sometimes, so if you hear that, I hope you remember what it means. If not, you can just rewind the video so you have the explanation again. So I tried to create a somewhat graphical illustration of our Obviously not very graphic software architecture. I will go through it part by part. I hope that it makes somewhat sense. I tried my best. So here on the top left, you have 3 blocks symbolizing applications. These applications are not part of the identity provider, but they belong to other teams in our company, in the Porsche Informatik, or also in the Porsche holding. These other applications require data they get from us. That's the whole purpose of the identity provider, to authenticate these applications and provide them with the data they need, but also only with the data they are allowed to receive. These incoming requests reach our identity provider, which is hosted on a cloud, an OpenShift platform, which then directs the requests to a backend, which I tried to symbolize with this very fancy looking cube, which after processing that forwards everything to the database where it gets the required data and then returns it all the way back to the applications. We're using currently an Oracle database as our main database, but we are going to switch to Postgres as our intention is to migrate to cloud entirely. So, a little more about the IDP architecture. It follows a very common controller service repository pattern, which is a staple for a lot of Spring Boot applications. However, due to an upgrade in the service level agreement of our identity provider, we needed to change the architecture just a little bit to have an alternative route in case the Oracle database, well, dies. So I present to you our new and revised IDP architecture. The first parts, as you see, are still the same. The user request comes to a controller, which goes to the service. And then we introduced a new component, which is a so-called adapter. And if everything works fine, if the database health check is positive, this adapter makes traffic flow to our primary data source, which is, just like before, the JPA repository and the primary, currently still Oracle database. However, if the Oracle database were to fail and the health check would come back negative, the adapter would notice this and redirect traffic to a backup data source, which consists of an Elasticsearch repository and an Elasticsearch database. So architecture of chaos means I will just go a little bit more into how we use this system to create chaos and implement chaos engineering. We have a total of 4 core components to our chaos engineering architecture. First, the PHS IDP, or Porsche Holding Salzburg Identity Provider, which you've already learned about. Then the Oracle database, which is our primary database supporting each and every function that the IDP offers. Then the Elasticsearch database, which provides core functionality in case the primary database is unavailable. Fun fact about this one, we didn't have to extra create it for this change. We already had this Elasticsearch database for rapid search index access, and we realized that, hey, we could actually use this as a backup database, and the whole transformation took just a single day, which was really a, let's say, success for our team. That was really cool. And what you haven't heard about yet, we introduced a new component, a small application called King Louis. By the way, if the name King Louis sounds vaguely familiar to you, I assure you that is complete coincidence and there is no copyright infringement intended whatsoever. No, really, it's kind of a joke in our team. We did use King Louis from the Jungle Book as the name for our application because, well, he commands a bunch of crazy monkeys and all of that. Yeah, monkey. You remember the monkey on the title slide? You're probably already thinking, what's up with the monkeys? I'll get to that in a second. I'll just give you a closer look at King Louis first. It's a, as you can see, very simple web application with a minimal GUI, graphical user interface, to manually launch and manage attacks. Then King Louis also offers jobs, which automatically run these attacks at scheduled intervals. And since the app requires authentication via the identity provider, because we don't want really everyone on the internet to be able to, throw our application into backup mode whenever they want to. But if it were to happen that the King Louis attack disables the login, we would need a backup way to, kind of stop doing that again. So we have additional HTTP endpoints, a URL to disable the attacks in case that were to happen. Hasn't happened, at least so far, which is good. So you're probably wondering by now, what are these so-called attacks? And for this, our application features a technology called Chaos Monkey for Spring Boot. Hey, there's the monkey. It's a really neat little plugin inspired by the Netflix show Chaos Engineering, and it is especially tailored for Spring Boot applications, which was perfect for our case. You can check it out if you're interested. It's a really cool plugin, and it's definitely very versatile in what it offers. So what does Chaos Monkey do? It provides 3 core functionalities for, so to speak, wreaking havoc in your application. One of them is endpoints. It provides either JVX or HTTP endpoints so that you can influence what your application does at runtime, which is fairly useful if you don't want to have to restart your application every time you want to run tests. Especially in production, that would be kind of problematic. All right, second, we have watchers. Watchers watch, as the name already says, certain files, classes, services, whatever you want to define in your configuration. And also, based on what you've defined in your configuration, these watchers will trigger certain events when the event you configured happen. That's a lot of configuration, man. And the third core functionality is it provides assaults. Assaults are, as the word already says, attacks on your system that could look, for example, like exception assaults, which means when a certain method of a certain class is called, no matter what, the application will always return an exception. There are also latency assaults, which means increasing your latency and see how that is handled. There are also even harsher assaults, for example, CPU or RAM assaults, where Chaos Monkey actively attacks your memory. We haven't used that yet, though. I'm not sure if we ever will, to be completely honest, but hey, who knows? Sky's the limit. So that was the theory. Now I have tried to create another little illustration to show you how this whole using Chaos Monkey in practice looks like. This is our default scenario, which is, well, hopefully every day. You have the layout just like before. You have the identity provider. You have the service, the backend, and then you have the adapter, which under normal circumstances forwards the traffic to your Oracle database. Chaos Monkeys are not doing anything. King Louis is sleeping and having a very good time not disturbing us. But if we then manually trigger these attacks, Chaos Monkey springs into action. And what it does is we use, in this case, an exception assault, which means that every call to our get data source returns a data source not available exception, which means we will get a lot of exceptions where every single request returns a failure. The adapter now notices this because the database health check comes back negative, and as a countermeasure, redirects traffic to our backup Elasticsearch. And it will do that for as long as it notices that the primary data source is unavailable. However, sadly, all good things must come to an end, and at some point it is time for our Chaos Monkeys to come home and go back to Chaos Monkey Island. Once that happens, the database health check comes back positive, and the adapter notices this again and redirects traffic back to the Oracle database as usual. So now that I've explained to you how our implementation of chaos engineering works, I would like to show you our live demo, our database outage, where we cut the access to the database in our QA environment. And I know I said that the principle is to test in production. We're getting there. But as I also said, we're not starting there. All right. As you can see here, this is the King Louis app. It might look a little different from the screenshot earlier because I'm on desktop and things are even smaller, so you see how minimal our user interface is. On the left, you have an overview of possible attacks that are currently not running. And on the right side, we have a list of available attacks. Currently, we have a main one, which is our database down attack. And I will just go and start it. Of course, confirmation screen. Do you really want to attack? Yes, I do. Let's create some mayhem. All right. The status is immediately updated to running. And on the left side, it'll take maybe half a minute or a couple seconds. All right. As the fact that there is no more server instances here means that the application has already realized something is wrong, can't access it. And right, there we go. The instances are already shown again, and the attack is currently running. How do we know this? If I now go to our QA environment, wow, there's slow internet here. Live, everybody. And I'm already auto-logged in, that's not helpful. Anyway, if I go back to the login screen of our identity provider, that's not the login screen. This is the login screen, there we go. There's a banner up top, which is in German, which is a very unfortunate considering this talk is in English, but it essentially tells you that currently the application is running in maintenance mode, which means that not all functions are available, but the core functions are, which are, for example, login, which is the main important thing. And I can show you that certain things do not work right now, which means where things on the database would be updated. Right here, it says, new privacy policy, I should look at that. Okay, let me look at it. And whoops, something went wrong. This little alert tells me this functionality is currently not available because there are maintenance being done on the application. As soon as the application is back under normal conditions, you will be able to access this page again. Really? Okay, let's see. I will just log out of here again, and I will stop all attacks, all single one, yes. All attacks have been stopped, great. The application has already updated very quickly, stopped, running is false and false. Now let me go back to our login page. Application cannot be reached. That's a lie, it is reachable. Still not reachable. Live, everybody. You gotta cut this a lot. There we go, it's back. I just didn't wait long enough. As you can see, the banner is gone and we can log in, just like we did earlier. However, this time, when we try to access this new privacy policy, Eureka, it works. All right. So, back to my presentation. This was our live demo of our database outage. As you could see, certain services were indeed not available, telling us that there really was a problem within the application. But certain core functionalities, such as login and some other important processes, were still supported. And if this presentation so far has still not convinced you of how cool our project was, it also won us our company's yearly Change Award in Innovation. Yay! On the right side, you see our chaos monkey, Martin, which I actually brought with me and forgot to put on the table. Oh well, nervosity. So, if this has convinced you, I just want to let you know that we are hiring. We are definitely looking for more engineers to work on such cool projects. And as you saw, there are still a lot of advanced principles we could and want to implement. And if you want to be part of it, refer me, and we got this thing on the road. Thank you very much for your attention. Some credits, and yep, that was it. Thank you very much.